In this question, it is given that three uniform spheres with masses 350 kilogram and mb that is 2000 kilogram and mc that is 500 kilogram have the xy coordinate as 0, 0, minus 80, 0 and 40, 0 centimeter respectively. The gravitational potential energy of the system and the change in its value in terms of increase or decrease if the sphere of mass mp is removed may be given as. So our aim is to find out the value of gravitational potential energy for a system of particle. So we know how to find out the value of gravitational potential energy for a system of particle. We need to write the potential energy for entire systems. So whatever may be the number of combinations for each and every combination, so we can write it. So first of all, let's see where these masses are kept. So according to the given orientation, we can say that first one was Ma mass, which is of magnitude 350 and which is kept at the origin. So its coordinate we can take it as 0, 0. And second mass Mb, which is of magnitude which is 2000, is kept at minus 80, 0. So minus 80, 0 means we can take it on negative x-axis. So it is somewhere over here. Its magnitude is 500 and its magnitude is 2000, and the mass which is kept on the origin is 350 kilogram, and distance between them in question it is given as nothing but 80 centimeter. It is given in centimeter, so we can just convert it into meter. So this is going to be 0.8 meter. Now the third particle, which is having a mass which is equal to 500 kilogram, which is kept at a coordinate of 40, 0. So we can say that this is basically kept at a point somewhere over here, plus 40, and y component is 0. And its magnitude is nothing but 500. So we can find out what about the total potential energy of system. And this distance is also given as 40 centimeters, so we can write this as 0.4. So we know that if there are three masses like m1, m2 and m3, so we need to write the total potential energy as a combination of potential energy of individual systems. That means due to m1 and m2 there is a potential energy of minus g m1 m2 divided by distance between them, let's say it is r12, same as like due to combination of m1 and m3, system is having a potential energy g m1 m3 divided by r13, where r13 is a distance between m1 and m3. Like that there will be potential energy between m2 and m3, so we can write it as minus g m2 m3 divided by r23. Now if you want to find out the value of total potential energy, we can just substitute the values. Let's say it is g into m1. In the first case m1 is nothing but we can take it as 2000 into m2 we can take it as 3350 divided by distance between them is given as 0.8 minus. For second case we can write g into m1, we can take it as 2000 into m3, which is nothing but 500 divided by distance between them is we can take it as it is 0.8 plus 0.4, which is 1.2 meter, and between m2 and m3 we can write it as g into m2 is nothing but 350 and m3 is nothing but 500 divided by distance between them is 0.4. So if you are adding all these things, we can find out what about the value of total potential energy. So this we can write it as minus g into the value of this one will get as around 875,000 plus 83333.33 plus 437,500. So if you are adding all these things, we will get the value as 2145833.33. We can multiply it with the value of its universal gravitational constant, 6.67 into 10 raised to minus 11. So we'll get something like 1431270.8.311 into 10 raised to minus 11, or which can be written as 1.43 into 10 raised to minus 4. So negative of this. So this will be the value of its potential energy. Now if you are removing any of its masses, then actually the negative potential energy is going to decrease. If you remove this mass, let's say mb, then the potential energy which was there due to m3 is going to disappear, or we can say that it was providing some extra negative energy. Now the negative energy is getting decreased. That means the potential energy is going to increase. If you remove any of these masses, then the potential energy is going to increase.